Why is it not? Oh, yeah, sorry. All right. The first section, we're going to do this we're going to start from the basics and go on from there. We're going to cover 7 things here and dealing with intro to graphing. Before we start that, what is a graph? Yes, that's one way. What else? Two or more, yes. And they're both correct. And you don't have to raise your hand. In college, it's just spit it out. So yes, graphs are a visual representation of equations with multiple variables of data. And that's bless you. And that's what you ever heard the phrase, a picture's worth 1,000 words? That's it. In business, whenever you do a presentation in the real world, you always do it with graphs. Very rarely will you have all the data because nobody wants to see that. So let's begin. In the beginning, in elementary school, you learned number line. What numbers did you start off learning? Well, 1, 2, 3, 4, and so on and so forth, all the way to infinity. What are those called? What are those numbers called? They're positive numbers, but what kind of numbers are they? What's that? No. No. You'll see why in a second. Not whole numbers. You're right. Whole numbers do contain those, but that's not the whole numbers. These are what are called natural numbers. Or we call them counting numbers. Because if you're ever asked to count, you always start with 1. It took a couple of 100 years later, after these numbers were invented, before we introduced this concept. If you have a hard time seeing, I would suggest coming up to the first row. Because yeah, I strongly suggest that. So now with the introduction of 0, and the 0 looks like a what? A whole. So this is the whole numbers. So whole numbers start with 0 and go to infinity. So just 1, 2, 3. The reason it took so long to invent 0 is because how do you define nothing? How would you describe nothing to somebody if they weren't next to you? Or if they were blind, how would you describe nothing? Everybody says, yeah, if I hold it here. But you could be philosophical and say, yes, you're holding air. So nothing, but it was a way to determine if a transaction was fair. Remember, all this stuff was because of commerce back in the first, second, third centuries, when they were, even before that actually, when they were trading, bartering livestock or farm produce. So it's like 3 chickens would equal 1 pig. So if I give you 1 pig, you have 1 animal. Now you give me 3 chickens, now we're even. So that's why it was hard to figure this. It's a state of equilibrium. It's a state of beginning. And then even more difficult, the next set of numbers are on the other side. Why would you need to have negative numbers? Well, to see, if I give you a pig and you only give me 2 chickens, you still owe me a chicken. So I'm negative. I'm losing. So that's just okay. So that's what the concept of negative came about. Once we have negatives, Those are called integers. Let's go from negative infinity to -2, -1, 0, 1, 2 to positive infinity. And the question was, well, what happens between there? What happens between 0 and 1? Because like I said, if I gave you a pig and you gave me 2 chickens, we're right here. What number is that? So how do we define numbers between integers? What's another name for it? Okay, but the decimals come from what? It starts with an R. Nope. Somebody said it, I heard. It starts with rat. Rational numbers. Because if you look at the first 5 letters, ratio. A rational number is any number defined as that. But there is one rule with this. A has to be less than B, a less than or equal to B. Because if A is bigger than B, then we have something called a mixed number. That means it's the bottom can go to the top. So that's another story. So now we have, but see, all of these, in other words, the whole numbers contain all the natural numbers. The integers contain all the whole numbers, which contain all the natural numbers. Rationals contain all the integers. So every number you deal with is a rational number. 2/5, -7/9, -2. Those are all rational numbers. Because everything, if it's nothing on the bottom, there's automatically a 1 on the bottom. All right, so, and this, if you look at this also, how did humans travel throughout history? What was the first way we traveled? By foot, so we walked. What else? By horses. Wagons. Yeah, bicycles and cars and yeah. So it's always horizontal. But train, yes. Boats. But now once we got the plane, we now have to go vertically. We have airplanes going up and submarines going down. Okay, here's another question. Why are these numbers, the natural numbers, why are they going to the right? What do you think about it? No. All those are good points, but they're not the reason why. Because think about it. What is algebra? Where did that word come from? Like, you ever hear of Al Jazeera? Al Qaeda? You guys ever heard of Al Qaeda? We've been fighting them for decades. It's an Arabic term. This is from Alhambra. It's just Al Jabbar. That's where it's from. This person who invented the stuff. But the Arabs, how do they read? Right to left, which makes all of mathematics backwards because the way they read it, it's not the way it's written. But because of how it went to Europe and the rest of the world, we read left to right. So that's how we started numbering left to right. Even though there's some parts in the world where if you look at their stuff, it's the other direction. So we start And we go from 1 to infinity, and negative goes to the left. Up is positive, and down is negative. And we call the point in which these two lines intersect. What are these two lines called? Axes. That's plural, axes. This is the x axis, and this is the y axis. The abscissa and the ordinate. I may have to mix up, but those are the two names that were originally given. Because X and Y really weren't used back in the old days. It was the abscissa, the the axes. What do we call a dot that we put there? A point. Let's define a point. What is a point? I know we use these words all the time, but do we know the definitions of them? Okay, what is it when it comes together? Yeah, you're right. It's X and Y where they come together. Well, where two axes intersect. You have a vertical axis and a horizontal axis. It's actually a location. So a point, we also call these, a point is represented as that, X and Y. And what is this called? It's a coordinate, yes. And now you see, remember there was an ordinate. You had the abscissa and the ordinate. Co means with the ordinate. So we have this. An X and Y point is called an ordered pair. Because if you ever get to go to calculus 2 or 3 or 4, or differential equations, you'll deal things with 3 dimensions where you have an X, Y, and a Z coordinate, which is what we deal with in our everyday lives. We live in a 3-dimensional world, so we have to have. That's why a corner of the room is a perfect example. You have the X and Y coordinate here, and then the Z coordinate going up. And if you think about it, submarines live in that world. So a submarine captain has to know exactly where they are horizontally, vertically, and laterally. So that's the ultimate in travel. Now, why does X go first? What came first? Yeah, the horizontal axis came first, and then the vertical axis. Actually, to be honest with you, X and Y wasn't the way they started. It was a horizontal and vertical. Yeah. The whole story behind that was because there was somebody who was sick in bed looking at a spider on the ceiling. The person who was sick was kind of named Rene Descartes. Rene Descartes. You may have heard what he invented something, a phrase called "I think, therefore I am." Did you ever hear that? Cogito ergo sum. That's Rene Descartes. He was a mathematician, philosopher of the 15th, 1500s and 1600s. Anyway, he was sick in bed one day, and he noticed a spider crawling on his ceiling. And so he told somebody to come get rid of it. And I was, where? Well, it's 3 this way, 4 this way. He pretty much said from that corner, go over 3 and go for however many. And so he defined a coordinate system. Which is also why what they use in maps nowadays. What is it? What is a person that deals with maps? What are they called? Ah, cart, cart. That's the reason they're cartographers. Because a map, if you ever seen a map, it has up and down, it's the alphabet letters, and horizontally, it's numbers, or vice versa. How many of you ever played a game of Battleship? Yeah, that's exactly what it's all about. Is you have a map where you put your battles, your ships, and the other person you have to keep them going. Anyway, so he invented it. And the X came for the reason they defined it X was alphabetically what comes first. X and Y is the second. We also have other names for these. For all the X's, we'll call those the domain. And the range will be the Y values. If you ever can't remember which one goes to which, think alphabetically. X comes before Y, D comes before R. Okay, so now we have our X and Y graph. What do we call this graph? Very close. Yes, that's do call it that. Yes. What's another name for it? What is because it's an operation, it's just a system of stuff that we use. What do we call this? There's a hint. I would play hangman, but I can't spell. Who invented it? Rene Descartes. So since he invented it, what kind of thing is it? Cart, coordinates one of them. Cartesian coordinate system. That's if you ever look it up, that's what it's called. The XY graph, Cartesian coordinate system. Now we see that there are 4 corners. Those are called quadrants. Quad means 4. There are 4 corners. If you were going to label these, how would you label them? Where would you start? You would start there automatically. I mean, forget what you've learned. This is if you invented it. If you invented it, you start up here. So you let's say call this the first one. Where's the second one? Then third one. Okay. Luckily, we didn't do that because that would be very difficult to memorize. There's no flowing sequence. It's like we do that because of typewriters, and that's when they're starting. But and we also do that because we have clocks. Descartes labeled these like this in Roman numerals, but he labeled them like this. Why? It has a flow because it goes from 1, 2, 3, but it's not like we see it. Well, you'd think that it's right to left because of Arabic. No. Remember, what we just did originally, we look at things in which way? A clockwise method. Did they have clocks back then? No. What do they use to tell time? Sundials. Where does the day begin? Where does the sun rise? The east. And it goes to, and then from the moon comes out. So it goes in that order. So when the sun comes up, it's in the first quadrant. It starts setting, and the third quadrant is now the first part of the moon. And so that's how you name the quadrants. We got to think backwards. If I gave you that point, where's the location? Yeah, 1, 3. Why 1, 3? Very good. Because where do you always begin? You begin from here. What is that name called? That place. That place is called the origin. Again, that's the reason it's called the origin, because all of these points begin from there. Now, to go to the point 1, 3, I start from there, go 1 to the right because it's positive, and up 3. How about that point? -3, 1. Because you have to go left horizontally first and then vertically. Actually, think about it. X and Y also horizontally, vertically. It's also alphabetical. How about that point? Right. So it's from here, go left 2, down 4. And that one. -3, -2. Very good. So everybody okay with that? Plotting points? As you see, there's that in the homework. So this point is in the first quadrant. This point is in the second quadrant, third. What do we notice the characteristics of these? In the first quadrant, both numbers are positive. In the second quadrant, it's negative, positive, because you go left, then up. In the third quadrant, they're both negative. Go left, then down. Fourth quadrant, go right, then down. So just by looking at that, with that, you can tell me which quadrant that number's in. Because this one, I go left, then up. That puts me in quadrant 2. Which is how radars used to work. The radar used to be in the middle, and they could see where any of the enemy airplanes or boats were coming from. So they could turn that direction. Okay, so far so good. Let's discuss the difference between an equation and expression. Yes. Very good. Has equal sign? No equal sign. Very good. So with equations, since it has an equal sign, you solve those. You can only solve something if it has an equal sign. Something equals something else. If it's an expression, all you can do there is simplify, combine like terms. That's all you can do. What is a solution? Yes. Is it always right? No, but you're right. Yeah, your solution is whatever you come up with. Yes. How do we know it's a solution? A solution consists of all values. A solution or consists of all values that make the equation a true statement, make it true. And we solve that by substitution, elimination, graphing, and there are a couple other ways that we'll cover. This will be our very last topic we're going to cover in this course. That's chapter 6. Solving systems of equations with those. I'm going to show you shortcuts to all that. So, for example, let's look at example 2. Given the equation 2x plus 3y equals 18. Tell me if both of these or if any of these are solutions to that equation. Let's look at the first one. This is an ordered pair. It's inside parentheses, ordered pair. This is my x value. This is my y value. So in place of x, I put -5. In place of y, I put 7. That's substitution. Now I work it out. Order of operations. Remember, in my classes, you never ever mention the word PEMDAS to me because it's wrong. It's wrong on so many levels. When you do algebra, when you do math, always treat the signs and the numbers separately. Because the biggest mistake, the most common errors in mathematics are because of the signs. That little negative sign is going to ruin your day. It's going to make so many wrong answers for you. So in the first one, you have positive times negative. Positive times negative is negative. 2 times 5, 10. Positive times positive, 3 times 7. Okay, here's another rule. We're adding, subtracting. Is the answer going to be positive or negative? And why? Why? Right. If you have opposite signs, take the sign of the larger number. and subtract them. 21 minus 10 is 11, positive 11. Is 11 same as 18? No. So that one is not a solution. Let's try the next one. There's my x value. So I have 2 times 3 plus 3 times 4. Positive and positive is positive. 2 times 3 is 6. Positive and positive is positive. 3 times 4 is 12. They're both positive. The answer is positive. 6 plus 12 is 18. So that one is a solution. Is that the only way we can do it? What's another way to do it? What's that? Very good. What's that called? No, that's exactly right. We could look at something called the intercept method. Yes. For what? The intercept method. There are two types. There is the x-intercept, and there's the y-intercept. The intercepts are where the graph crosses the axis. You won't need your computer. Use pencil and paper. You can't take math notes in a computer. It's impossible. An x-intercept where the graph crosses the x-axis. So the y-intercept would be where the graph crosses the y-axis. Open that up. So I leave it open. So in our graph here, what is the x-intercept? No. No. Okay, let me change the definition then. Just 0? It's the location. It's the location. So where does it cross the? You're right. It's -2. But what is that location? -2, comma 0. That's the x-intercept. So what's the y-intercept? 0, 2. X goes first. Yeah, so the intercept method, it makes it much easier because for the x-intercept, here are your steps. First step, set your y value equal to 0. And then solve for x. The x-intercept will always give you this kind of number. So the steps of finding the y-intercept, because it only crosses the y-axis, you don't have an x value. So set x equal to 0. And then solve for y. And there's your location. Will it always work? It'll work, but it won't give you great numbers. It's great if it gives you integers. If it gives you decimals, don't use it. Because if it gives you something like 9/74, what are you going to do? Where are you going to plot that? So if it gives you anything but an integer, don't use it. Let's look at this. Let's look at the last one we did. We had 2x. Let's find the x-intercept and then the y-intercept, if they exist. So we have 2x plus 3y equals 18. 2x plus 3y equals 18. To find the x-intercept, what do we do? Set y equal to 0. Basically, anything times 0 is what? Yeah, so basically what that means is delete anything that has a y next to it. And then solve for x. How do we get x by itself? Why do we divide by 2? But why do we do it? Because it's, yeah, when you solve for variables, it's always a process of opposites. Since it's 2 times x, we have to do the opposite. So we divide by 2, both sides. 18 divided by 2 is? So what's my answer? Yes, 9 comma 0, because we're looking for the x-intercept. It's a location. So the x-intercept is 9 comma 0. And the second one, the y-intercept, our first step, set x equal to 0. So that's gone. So we have 3y equals 18. Divided by 3. So my y-intercept is 0 comma 6. Now it's easy to graph. Just plot those 2 points, connect the dots, and you're done. I'm going to try to minimize the chances of errors you guys have. Again, remember I told you the negative signs. Treat numbers and negatives separately. What if we had this? After we got rid of the x, we had if we had that. Originally, we had 2x, and we got rid of this because we said it equals 0. So we have negative 3y equals 18. I know what you're going to say, but I'm going to stop you. I want to hear it from you anyway. How would you get y by itself? Yes, never divide by negative numbers. Because again, the more stuff you have to write at one time, the more chance of mistakes you're going to have. Especially the larger equations we have. Are you going to put negative under everybody you divide by? No. So the rule is, here is the simple rule to alleviate that. If you have a coefficient that's negative and you want to get to the variable, first, change the signs across the entire equation. Change the signs. In other words, move this negative to the other side. Now you don't have to worry about writing anything else. Now we just divide by 3. Because we may have equations that leave you like this. What would you do to solve for y? You're solving for y, not x. You're going backwards. So in order to solve for y, what do you have to get rid of? There's a negative first. Change everybody's sign. So make that a 3y, make that a negative 7x, make that a positive 5. Just change all the signs first of all the coefficients. And now all you have to do is put a 3 below everybody. Trust me, that's going to save you so many chances of mistakes. Treat them both separately. Because what you're really doing is you're multiplying by -1 across the board. But it's much easier, instead of multiplying by -1, just change the signs. Even if it's a fraction. What would be your first step here? Change the signs. So that's going to be a positive 3y, a positive 4/5x, and a negative 6/7. Then you're going to divide everybody by 3. Now, this is where a lot of people get confused. Remember, every number is a fraction. So this is 3/1. The rule is this is a compound fraction. Whenever you have a fraction, whenever you have a fraction over a fraction, like we have here, take the top fraction, leave it alone. Multiply the flip of the bottom. Reciprocate it. And then multiply them. So we have AD over BC. That's the same thing as that. So what we would do here is 4/5 times 1/3 x 6/7 times 1/3. What's the rule of multiplying fractions? You have to do what? Only when you add and subtract do you have a common denominator. Whenever you multiply fractions, first step, can anything on top and bottom cancel? Always simplify. If nothing reduces, nothing reduces here, then top by top and bottom times bottom. Can anything cancel here? Anything on the bottom, anything on top? Because when you multiply them, it's like this. Can anything on the top cancel with anything on the bottom? This side's saying no, this side's saying yes. Yes. How about the 3 and the 6? 3 goes into 3 once, 3 goes into 6 twice. So we have 2 times 1 is 2. 7 times 1 is 7. So there's your final answer. Now imagine doing all this with a negative when you divide by negative. Think of all the writing extra you do. So get rid of the signs first and then do the rules of math. And don't worry, we're going to go through these rules all throughout the semester. I will always remind you of the rules as we go along. Typically what I used to do is the first week, 2 weeks of the semester, I'd go back over all the rules of math. But that starts us negative 2 weeks into the semester. And so we're rushing at the end. So that's why I'm going to do it as we go along. So the X and Y intercept are perfect methods to graph equations. Okay, if I'm going too fast, please stop me. If I'm going too fast, just throw a $10 bill at me. They hurt more. All right, got it? All right, let's look at example 3. Graph this equation. We just did that one. Forget, let's do number 4. 3x minus 5y equals negative 10. Graph that equation. All right, so let's look at the intercept method first. The x-intercept, y-intercept. Okay, for the x-intercept, what do I have to do? Make y equal to 0. So in other words, that's gone. That's y is 0. Then solving for x. Uh-oh. That one doesn't work. So we can't use the x-intercept. How about the y-intercept? Get rid of the x. So we have negative 5y equals negative 10. Since there's a negative coefficient, change the signs. So we have 5y equals 10. So we know that at 0, 2, we have a point. We're halfway there. What kind of equation is this? Because one thing I'm going to want you all to be able to do by the end of this course is by simply looking at the equation, you can tell me what the graph's going to look like. So what kind of equation is this? Why do we know it's linear? What is a linear? A linear equation is a straight line. How do we know it's a straight line? Look at the variables. There are no special operations, no exponents, nothing like that. So because of that, we know it's a straight line. So to draw a straight line, what do we need? We need 2 points. Once you have 2 points, you connect the dots and there's a straight line. So with this equation, how do we find another point? If we plug in 2 for y, x is going to equal what? 0. So we can't do that. Okay, let's do that. Let's do that. So how do we move the x from here to there? How do we do that? So subtract 3x from both sides. X minus 3x is 0. So we have negative 5y equals negative 10 minus 3x. Change the signs. So we have 5y. We can divide everything by 5. Now, the problem comes here. The choice of x is important because the number we get up here better be divisible by 5. If it's not divisible by 5, because think of it, if we have a 19 up here, is that divisible by 5? Is 25 divisible by 5? Yeah, so what we have to do, the choice of x is important. So what x are we going to use? We can't use 0 because that's already been used. If we use 1, we get 13. That's not divisible. If we use 2, that's 16. That's not going to work. If we get 3, that's 9. That's 4 won't work. That's 22. Well, yeah, that's right. We get to the point. You have to find a value for x that's going to make the top divisible by 5. So we're going to use 5. We're saying that x is equal to 5. We have 10. 3 times 5 is 15. That equals. So 10 plus 15 is 25. Divided by 5 equals 5. So x equals 5 and y equals 5. These are our 2 points. So we come to our graph. 5, 5, and connect the dots. There's my graph. And yes, that is the next section we're going to do. We're going to find a better way of using that equation instead of what we just did. Because now it's just, at this point, it's simply trial and error. Till we get a number that's divisible by 5. Example 5. Y equals x squared minus 9x minus 12. Is this equation linear? No, so it's not a straight line, which makes it more difficult for us. Because the method that's you first get into is what we just did, is just plug in some points and see what you get. We pick some values for x, plug it in there, and that gives us a value for y. But will 2 points do enough for us? No. Because what is this graph going to look like? It's a quadratic, because that's a 2. It's a quadratic equation. Which means the graph looks like this. And we're not going to do this one yet, but we're going to do this in a couple of days, a couple of weeks. We'll be able to solve this one. That's better. It's Nick. Yeah. Thank you. So using the trial error method of plugging some points, now, because if you pick all your points on this side, you only have half the graph. And you have to know where the bottom part is to find other points. So I don't know why they introduced that yet, because we haven't discussed quadratics yet, or any higher order polynomials. One, two, three. One, two. Let me pick 2 points. Here's one here and one there. We're going to stick with linears for right now. If I give you that information, what all can we find out about that line? We can find the slope. What else? The x-intercept and y-intercept, but not just yet, we can't. If they cross at integers, yes, it's easy. But if they don't, then we can't find it at this point. What else can we find out with this? Midpoint? What is a midpoint? Not a linear. It's a line segment. Because a line goes on infinitely both ways. There is no midpoint in infinity. So a midpoint is a location that's halfway between 2 points on a line segment. Yeah, it's a point. What else can we find? The equation. Very good. Which I'm simply going to call EOL from now on. This is your first point. This is point A, and this is point B. The distance between any 2 points. So to find any of this stuff here, we first have to know the locations of these points. We have to know the separate coordinates of each of these points. So because we read left to right, the first point we get to, we'll call that one point 1 with a subscript 1. Its location is what? 1, 1, which means it's x1, y1. The x component of the first point, the y component of the first point. Because we have to be able to distinguish which values are we talking about. This is point 2. So it has its components, x1. So what is its location? So let's label x1, x2, y1, y2. Let's label those first. What is x1? X1 is the x value. The subscript tells me which point I'm looking at. It's the x value of the first point, which is 1. What is x2? It's the x value of the second, which is 4. What is y1? It's the y value of the first one. No, I'm glad you said that, because that's the reason we do this. And the y value of the second point is because typically when students, if they just go straight to the points, what they're going to do is x1, x2, y1, y2. Because it's much easier to read that way. So that's why I want you all to label these points first. This is the x value of the first point, the x value of the second point, the y value of the first, and y value of the second. So let's look at slope, because let's see here. We won't be able to do these two just yet, or the equation. So the only thing we're going to find out now are the slope, the midpoint, and the distance. What is a slope? It's defined as rise over run, but what does it really mean? But you're right, it is rise over run. But what is, in mathematics, it's the vertical change over horizontal. Let's use some math symbols here. That's the equation of a line, not slope. Instead of writing the word slope all the time, we use the little m. And whenever you discuss change, that's the D, the delta. It's a vertical, so that deals with the y-axis over the change of x. So this is how you'll see it in math books. The slope is a change of y over change of x. What is the change? So the horizontal change from this point to that point. How far is it from 1 to 4? From 1 to 4, it's 3, isn't it? How about if I had 7 to 95? How far is it between there? 88. How about from 10 to 100? So how'd you get that? You subtract the second from the first, the bigger from the smaller. So this is my x value. This is my first one, the smaller one, and this is my bigger one. So the formula is x2 minus x1. That's the horizontal change. So it's x2 minus x1. How about the vertical change? What's that going to be? Right. There's your formula for a slope right there. So let's calculate it. What is y2? What is y1? What is x2? And x1? So it becomes, my slope is 4 over 3. Do not change that to decimal. Do not change that to decimal. Why? Exactly. I need to know the vertical and horizontal change. What this thing tells me a lot. Remember, it's vertical, so it's positive, so it goes up. And bottom is always positive to the right. So from the first point, I go up 4. 1, 2, 3, 4, and over 3. 1, 2, 3. I get to my next point. And I follow the same thing. 1, 2, 3, 4, 1, 2, 3, and I got the next point on the line. So infinitely, all the points follow this roadmap. So yes, we can say rise over run, but it's actually rise or sink over run. If the top is positive, it's going up. If it's negative, it goes down. The bottom always goes to the right. Why is that? Is because whenever you deal with fractions, yes, the denominator can never be negative. So if you have a negative in front, it only belongs to the top number. Now the reason why. This is the reason why. When you add and subtract fractions, just this is positive 3/4 minus 4/7. Since the common denominator, that goes there. And then we do the operation with the top. So the bottom number is always going to be positive. 4 is bigger than 3. 4 is negative. The answer is negative. 4 minus 3 is 1, and there's that value. So the top number only is negative, never the bottom. Find me the slope between these. You could do it, yeah, but you trying to get confused. That's why I like it this way. You get away from that format like this. But yeah, you can do that, yes. So the first thing we do, label the points. What is x1? This is 0.1, this is 0.2. So this is x1, y1, x2, y2. So x1 is -3, x2, y1, and y2. If you, it's much easier if you do that, because if not, again, guarantee you, it'll usually happen. So y2 is 1 minus y1 is -5. X2 is 7 minus -3. So the first thing you do when you have two signs together, do multiplication, order of operation, do multiplication first. Don't use a calculator. I don't want anybody use calculators in this class. Your brain is faster and better in the calculator. It just needs to be working out. Your whole high school, junior high, elementary school careers ruined your brains because it lets you use calculators without thinking. You need to know what's right, what's wrong. So order of operations, you have to do multiplication first. So negative times negative is negative times negative is positive. 1 plus 5 is 6. 7 plus 3 is 10. There. No. ¿Por qué no? You can simplify it. 6 is made up of 3 times 2. 10 is made up of 5 times 2. They both have a 2 in common. Always, always, always simplify. That's your slope. So that's the slope equation. Let's talk about the distance between the 2 points. The distance between the 2 points. The only formula we know for distance is that formula. What is that formula called? It's called the Pythagorean theorem. What does it define? If you have a right angle, meaning it's 90 degrees, so that's going to be A, this is going to be B, and that's going to be C. What the Pythagorean theorem says is the square of the legs, these are the legs, of a right triangle, the sum of the squares of the legs of the right triangle is equal to the square of the hypotenuse. Basically, all it tells us is how far it is from A to B. That's what C tells us. A tells us how far it is from B to C. B tells us from A to C. Those are all distances. So I have this equation. So well, let's just do it for, how do we know the distance between two numbers on the bottom, on the horizontal axis? How did we do it a second ago? How do we find out how far it is from 1 to 4? Yeah, we took the second number minus the first. So we do that simple. So A represents x2 minus x1 squared. B is vertical. Y2 minus y1 squared. And C is the distance between A and B. So that's one formula for it. But if we're looking for the distance by itself, how do we get rid of the square? We have to square root both sides. And you're going to see equations in both forms. If the answer is a square root form, that means that the distance is just a distance. If it's not, then it's a squared term. So what's the distance between point A and point B? We have here right triangles. Where this is x1, this is x2, this is y1, and that's y2. So the distance between those two, x2 minus x1, so it's 4 minus 1 squared, 5 minus 1. We also have them defined earlier. 4 minus 1, 3 squared. 5 minus 1, 3 squared is 4 squared is 4 times 4. 9 plus 16. Square root of 25. So the distance between them is 5 units apart. Okay, last thing real quick before you go. Oh, we're not going to do an extra example there. So let's look at midpoint real quick. The midpoint is just that. It's a point halfway between two endpoints. We use the capital M to distinguish this one. It's a point. It's a physical location. So we have to have an X and Y component. What number is halfway between 1 and 4? How would you find that out? 1 plus 4 divided by 2. Right. What number is between 1 and 5? So it's 1 plus 5 divided by 2. So this location is 2.5 comma 3. So you're taking the average. You add the two numbers, divide by 2. Add the two numbers, divide by 2. That's the formula for it. So next Tuesday, we'll finish up this and do the next section. We only have to do circles next. No, those are what we do in class. So that, no, you keep those. You keep those. Those are yours. So I'll give you some for every section we do. That way you don't have to write down all the formulas and everything else. It's all there.